Hello, everyone. Thank you for joining our training today on INRIX Roadway Analytics. Before we get started, I just want to run through a couple quick housekeeping items. Everyone's muted and will be throughout the training. If you have questions during this training, please go ahead and submit them through the GoToWebinar questions window, and we will answer all the questions that we have time for at the end of the training. And the training is going to be recorded today, and you'll receive a link to that recording within 24 hours of this presentation. And we'll also make it available within the Roadway Analytics platform. So you can look for it there in the help section. Okay, so let's get started. I'm going to turn over the mic to Angela Salerno, and she'll get started with the training. Thank you.
Hi, my name is Angela Salerno. As Ali mentioned, I'm a sales engineer with INRIX, primarily in the public sector, but can answer questions for enterprise or auto as well. So I'm going to go ahead and get started. If you can't see my screen, go ahead and just write a note and let us know, and we'll try to help you out there. Okay. So whenever you go to analytics.inrix.com, which is available on any web browser as long as you have internet, we highly recommend you use Google Chrome or Explorer, but it's available on any platform that has internet. As soon as you open up the tool, this is kind of the first page you're going to see, and it's the overview page. These won't be populated, so I'll kind of show you how to populate these as well. And this is where you actually make your study. So it's where you're going to get all of the information that you need to be able to visualize easily the data. To go back a little bit, our tool sits on top of XD data, so that's our segmentation, our road segmentation, all the way back to 2014 on a global scale for every road that we have covered. So when we created this tool, the point was to both allow you to easily visualize that data, and in addition to be able to download that data directly. So when you download the data, you're going to get a whole bunch of data. So the ability to visualize it quickly is a good one, at least for kind of initial analysis. So starting with the overview page here, there's these three sections. One is choosing the location, and you're able to choose either a corridor or a region. Hopefully we'll have time at the end to show you the region. You're able to choose dates. So this is where you can do kind of year-over-year dates, or if you wanted to do dates during holidays versus non-holidays, or dates after specific construction projects, this is where you would do that. And then granularity. So how granular do you want that data coming back? As I mentioned, we have data globally from 2014, and we have that on each individual segment on each individual minute. So that's a ton of data. So I like to choose the 15-minute granularity. It gives a quick view. It runs a little bit faster, and it's a little bit less data, but it's a little more granular than the hour. So that's kind of a happy medium for me. So starting off with how to choose a corridor, so how to choose a region, we're going to start off with corridor. If we go in here, I've chosen two different roads. I'm going to show you what I've chosen, and then I'm going to show you how to choose that. So this is the one I've chosen. I've chosen 101 in Los Angeles. So that was just me viewing that. If I wanted to choose a road myself, I would click on this add button. And then I would center on the region that I'm interested in. So if I weren't on Los Angeles, I would go ahead and just center on that. And that goes to the area that I'm wanting. There's then a few different options of how I can choose a roadway. So if I wanted to choose 101, I can actually use this search roadways. This is a great tool if you're wanting to get the entire roadway for an entire area, not just a section of that roadway. So I could choose 101 here, California, and then I'm going to choose the county because I don't want 101 for all of California. I just want it for that individual Los Angeles county. I can choose the direction if I'm only interested in northbound, southbound, etc. And I can choose the road class as well. So I'm going to go ahead and search. So now it's choosing 101 in the Los Angeles area. It's choosing all directions because I chose all directions. So you can see all of the different segments down here listed. and then I can see it in this screen as well. And then if I decided I didn't want any piece of this, I can actually click on an individual piece. I can delete that, and that'll delete that individual segment. That deleted one direction of that, and I can delete that. I can also, if I don't want any of it, I can just clear all of it, which is what I'm going to do because I want to show you another way to select a roadway. So if I can additionally select a roadway by selecting corridors. This is my favorite way to select a roadway because often I'm wanting to look at the smaller corridor, so I don't want an entire road for an entire county. So this is what I like to do. And it's very simple. You just put waypoints and it's going to connect those waypoints for you. So for example, if I'm wanting to do Highway 10, I'm just doing a normal left click on this. And then as soon as I left click on that, it's going to come up and zoom in and show me all of the different options that I can choose based on what I clicked. It's going, did you mean westbound? Did you mean eastbound? Did you mean this segment over here or the segment back here? So I'm going to choose eastbound, and I'm going to choose this segment here rather than, say, this segment that's in front of it. And then I'm saying I kind of want to go through this intersection over here, maybe see as it's going into the fashion district. So then I would just do another waypoint right here. And again, I need to make sure I'm choosing the correct direction so that they'll connect. And then that connects for me. And then if I actually decide that I want it to go a little bit further, I'm actually interested in it, kind of how it intersects with the Los Angeles River, then I would click again, and again, it zooms in, says, where do you want to go? Which option are you trying to choose? I'm going to choose this option going on, and then it connects it for me. So you can keep doing that kind of and find the exact corridor that you're interested in looking at. In addition, I can still remove all of these if I'm wanting to, or remove an individual section as well. So that was that additional section that I added at the end. So I'm going to go ahead and cancel this because I already chose the roadways that we wanted to look at. So now we have these two roadways. Again, I can look at them. I can edit them. I can just go into that edit button and take a look at the roadways that I selected. So here's 101 South, and here's 101 North. I'm taking a look at these. And then I want to choose a date range. What am I interested in here? So in this case, I've chosen a kind of a typical week in March in 2018 and a typical week in March in 2017. So I'm doing a year-over-year analysis of this 101 and seeing if there's been big changes or how the roadway looks over time. You can additionally add another year or a different time. So if I wanted to, again, select another time range, you can select up to 7. I would go here and say I wanted to select something in 2016. I would just click over here. So again, it comes up like this. And then if I wanted to select a year, I click on this right here. That goes to 2018 or 2017. So I can go back to 2014 and choose a date range that I might be interested in. So in this case, maybe I want to look at all of March. So I'm going to select March 2017. So now I've selected all of March, and maybe I'm actually interested in all of the Wednesdays in March. Then I can actually deselect some of these. And now I'm going to be able to look at all of the Wednesdays in March for this 101 corridor, South and North. Or I could look at all of just the weekdays here. And then I would click Save, and that would bring me to, and that would bring up that additional date as well. I'm going to go ahead and cancel because again, I've already run these. But here, what I've done is I've chosen that 2018 March timeframe and 2017 March timeframe, just a typical week. And again, I've only chosen those weekdays because that's what I'm interested in right now. And then this granularity here, what granularity do I want that data coming in at? And again, I like to choose the 15-minute, especially for a quick visualization and even for a data downloader, which I'll show you in a bit. It just brings things up quickly and it'll allow you to see it a little quicker. Okay, and then I would just click Save. If I click Save like this, I've already created this study right here, so I would just save over it. So if I changed anything, it would save over it. If I wanted to change it as something else, which is often going to happen if, say, you are interested in a specific corridor and you're running it kind of every week or something like that, you're going to probably need to just change the dates. And that's when you might want to use the Save As and then save it as something with the date as well. And then as soon as you Save As, that's going to show up down in this bottom here. So you're going to see this 101 south north year over year, which is this one up here. But if I saved it as something else, it would show up down here as well, and then I can reload it. Okay, so as soon as you click save on this, that's when these are going to populate. So when you first open up the tool, you're only going to see this overview tab until you click the save button. As soon as you click that save button, the performance charts, the congestion scan, and the bottlenecks will show up for the corridor selection, as well as the data downloader. Before that, you won't see those modules. So let's go over and take a look at what these modules look like. Okay, so I'm going to change this over to travel time, because it's often what you'll be using. And then I'm going to change this to custom scale. Okay, so go over that in 1 second. Okay, so automatically when these performance charts come up, it's going to go to this auto scale option. The auto scale option is going to just kind of make it the most visually appealing for that individual graph. Often you'll be doing a comparison, for example, this 101 south, 101 north. I really want to see what they're like in comparison to each other. That's when you'll use this custom scale. And you can take a look at, you can see that the travel time is being shown equally with the y-axis being 40 for travel time in minutes versus the auto scale, where again, it's going to kind of show each of those individual graphs in the most visually appealing way. So I'm going to change it to auto scale again, just to see both of those options here. So now to the auto scale, we see 15 on this y-axis over here and 35 on this y-axis over here. When this first comes up, you have the option to choose a different metric. Again, I chose travel time. It'll automatically come up on speed. All of these different metrics are further explained in the help section, which we'll go over at the end. But it allows you to see all of the data for a particular corridor rolled up on that particular metric. So what we're seeing here on this day view is on this x-axis here, we're seeing an hour-by-hour look at that entire corridor. And we're seeing what a typical 8 a.m. looks like, what a typical 10 a.m. looks like, what a typical 12 p.m. looks like for that entire corridor. So again, if I chose a very small segment of a corridor, a very small piece of 101, it's gonna roll up and say, what does a typical 8 a.m. look like for that entire corridor? If I chose a very long piece of the corridor, if I chose for the entire Los Angeles County or even all of California, again, for this particular performance chart, it's going to roll up all of that data and say that's what that entire corridor looks like, kind of a typical 8 a.m., a typical 10 a.m. So it's just good to keep in mind as you're doing this, that's how it's rolling up the data, and that's what you're looking at here. As we go on to congestion scan, you're going to have a better look at how you can view those corridors on a segment-by-segment level, so on a more granular level, rather than kind of just the entire corridor as a whole. So they're very good to use in conjunction. So as we're taking a look at this, you can see that these 5th and 95th and 25th and 75th percentiles show up as well. I'm going to deselect these just so it's a little clearer to look at first. So we're looking at this, this 101 south. We're seeing that it's very clearly an evening commute road with the travel times being very high, kind of starting at around even as early as 12 and ending kind of at the 7:30 time frame. And we see the orange, which is represented by the 2017, actually has a little bit of a higher travel time than the blue, the 2018. So that's a little bit different than what you would typically see, because often you would see year over year that the next year would actually have a higher travel time, more congestion. So we might want to look at this and say, what kind of changes do we make on this roadway? Maybe what public transportation do we put nearby, and that's caused this kind of decrease in travel time on the roadway. And then, so this is the average. Again, this is the very average of what does a typical 10 a.m. look like, the mean, the average. But if I want to look at those kind of ranges, so if I do this 5th and 95th percentile, now I'm looking at the range of, kind of what the speeds are on the road over that time. So again, over that March week time on that corridor, what are kind of the higher and lower speeds. And again, I can look at that for the other piece as well. So I'm seeing that these are pretty typical of what you would see. If you look over here, you're kind of seeing these even higher kind of ranges here. That might be something that you might be interested in looking at. So I'm going to click off of this. But you're seeing a pretty big range here, kind of at some of these times here. We are seeing some of the travel times actually going quite a bit higher than this average here. So that might be something that you wanted to look at, kind of where that's happening and when that's happening. As you're looking at the congestion scan and looking deeper into things, this might be a time and an area that you might want to explore, kind of looking at what segment that is occurring on. Okay, and then on this road, you can additionally see that this is actually, it is a morning commute road, but you're also seeing this evening commute road, evening commute be a little bit high as well. So again, if we do this as custom so that we can see this at the same time, you're seeing this evening commute for this 101 South is pretty high, but actually when you look at the 101 North, even the evening commute, which is less than the morning commute, is actually a bit higher than that. So it's just something to look at. The 101 North seems to have a little bit more congestion and issues than the 101 South. Okay, so again, what we're looking at here is all of this data for that particular corridor that we chose, so that length of road that we chose, rolled up and saying, this is a typical 8 a.m., this is a typical 9 a.m. When we look at the week view, I'm going to go ahead and auto scale this again. When we look at the week view here, what we're seeing is instead of it being rolled up on a particular hour, it's rolled up on a particular day. In this case, I chose only a week, so we're just seeing kind of that Monday, that Tuesday, that Wednesday, that Thursday. But if you took, for example, an entire month or an entire year, you're going to get a really good view of what does a typical Monday look like, and what does a typical Tuesday look like, and what does a typical Wednesday look like. And that's a very good tool, especially when you're kind of looking at those year-over-year studies. In terms of kind of looking at that entire day, sometimes it's not quite as useful to look at the entire day. This is where you're wanting to look at these time ranges, where you're not really wanting to know what does a Monday look like. You're wanting to know what does a Monday look like for the entire year of 2017 from 6 a.m. to 9 a.m. because those are the problem areas that I know we have. And so that's where you add these time ranges here. So I've already added in the morning time range and the evening time range, but you could add in a different one that's interesting to you as well. And then once that's done, it's going to ask you to kind of rerun that report, and then this will show up here. So what we're seeing right now is this morning time range in that 2017 time versus that 2018 time, and we're seeing a comparison between that morning time. In the southbound, we're seeing that they're pretty typical during that morning commute. In the evening commute, we're seeing some differences here where, again, we're seeing that travel time be a little bit higher in 2017, which, again, is a little bit different than what we might expect. And then, again, we're seeing the same thing over here where we're seeing kind of a slightly, be able to compare the evening commute. In this case, when we look at this northbound, we're seeing the 2018 actually has a higher travel time than 2017, which again is kind of a little bit more typical. As population increases, the congestion on that road is going to increase, and the travel time will increase as well. So again, I can click on this 6 a.m. time, and now I'm seeing that morning commute for each of those days a week. You can see that the Saturday and Sunday are not showing, and that is because I chose not to look at Saturday and Sunday. In all of these cases, and in the previous one as well, you can actually download this data. So if I download a PNG, it'll actually download an image of the graph itself. I can additionally download the report data, and that's going to give me exactly what I'm seeing here. So where I'm seeing kind of these travel times for these different times, it's going to give me essentially that data in kind of a offline format. So again, if I open this up, this is exactly what I'm seeing here. And again, I could do the same thing with the day view as well. This is great for if you're wanting to share the information or if you're wanting to add that to a presentation. And here is the data that you would be able to see kind of coming offline. Again, you can see this for the week view, but you can also see it for the day view, where I'm opening this performance headers, and that's going to have kind of the headers for the document itself. And then the data that we're seeing. So again, we're kind of seeing each of these individual metrics. Again, each of these metrics are more described in the help section. But we have speeds, travel time, comparative speed, congestion percentage, and we're seeing for each of those days, kind of what the average speed is for each of these different days here. as well as the average travel time, comparative speed, etc. All right, so if we move on here, this last view here is the cumulative frequency diagram. And this is a great tool to use if you're kind of doing signal analytics. It's really to show you consistency on a road. So how consistent is your roadway, and kind of what's happening on it in terms of how consistent the travel time is, or the speed, or whatever metric you're wanting to use here, travel time or speed. So if I look here, what I'm seeing is a really quick rule is the more vertical I'm seeing it, the better it is. That means that we're having a very consistent travel time. It's a little bit, it takes a little bit of getting used to if you haven't looked at it before, but what we're seeing here is if I go to a certain point, for example, right here, we see this value, this 67.62%, and we can see that that value is saying that there are 67.62% of the speed values that are at a 5-minute travel time, the travel time values that are 5-minute travel time or below. So again, if you had a very, very consistent consistent roadway, you would see that the line would be very vertical as you go up it, and it would kind of show you that most of them are kind of within this very small range, where we even see that from here, from 100% to 67%, we're seeing that the travel time only changes by about a minute. So we're seeing a very, very small change here on this 101 south in that morning time range. If we go over here to this evening time range, which is again where we are seeing a lot of the increased travel times and decreased speeds, we can go over and we can see that this line isn't quite as vertical, and this range of travel time is a little bit higher. So we're going over here and we're seeing this 38.88% have a travel time of 7 minutes or lower. And then as we go up here, we're seeing that 53.05% have a travel time of 9 minutes. And we go over here and we're seeing that travel time of 13 minutes at almost at 100%. So we're kind of seeing the range here, and we're seeing it's a little bit wider. We might even see something a little wider on this 101 north, because we were seeing even more here. So yeah, you see a little bit even of a wider travel time on the 101 north as well. So this is really a way to just show you consistency very, very quickly, kind of how your roadway is looking. Okay. I'm going to stop for a second, and just if you guys have any questions, please make sure that you're writing them in the chat box. I'm just going to give you just a few seconds just to open that up for you guys. Okay. I'm going to go ahead and go on. I just want to remind you that to please write in that chat box and write down any questions that you're having. We love to hear them. Okay, moving over to congestion scan. I'm going to take off a few of these just so it's a little clearer. And I'm going to show the map player again so it's a little clearer. So as I said in the, I'm going to go ahead and change this to speed as well.
Before you get started, Angela, there were a couple questions pertaining to the performance charts. I'll just rattle them off really quick for you, and if you're able to quickly answer them, I know we have to keep moving, but we have one question that says, what is the minimum length of the segment? Right.
So that is actually a common question, and I'll just take this a second to just show you the FAQ section. So if you go over to this hamburger on the left-hand side, there's a couple different options here. One is just the roadway analytics. I'll show you the traffic and safety, which is in kind of an alpha stage right now, but I'll show you that at the end as well. There's also this send feedback piece here. So this is where you would kind of put in information about features that you're wanting to have, as well as errors that you're encountering. This goes directly to our engineering team and to us, and it's kind of your direct communication with us, and it's it's where we draw our information about how to improve the tool. And then if you go to this help section, you're going to see common FAQs, as well as a guide to roadway analytics, which will kind of take you through each of the individual parts of the roadway analytics tool. If you go to this FAQ section, it's going to give you a lot of that information that you're wanting to look at. So that question that you just asked, which is what is the typical length of an individual
minimum length?
Yeah, a minimum length of the typical length of an individual XD segment. So you're going to be able to see kind of the range of that XD segment length here, where you're seeing that 22% are less than that 100 meters, between 100 and 500 meters are 19%, et cetera. The minimum length itself, I would have to look at, but I can get back to you on that one as well.
Okay, and just one more. The question is, can you change the 75% or 95 percentile speeds to 85%?
That is not something that's currently in the tool. As I mentioned, as you have feedback like that, please send it to us. We do change the tool quite often, and so we need that information to kind of just make adjustments based on what you guys are actually needing. So if you go to here and you submit this feedback, go ahead and put in that information that you would want that percentile speed to be able to change that percentile to 85%. And then even if you can give us a use case, that even makes it a little more easy for us to understand what's going on as well. So you could just give a kind of a quick sentence about what's going on and why you're needing that.
Thank you.
Okay, so moving back over to congestion scan. As we go through this, we can kind of take a look at a more granular look at that corridor. So I really like to use this in conjunction with the performance charts, because where the performance charts are showing, again, a summary over that entire corridor, the congestion scan is giving me a look at what's going on each particular segment. So I'm looking right now at 101 South. I'm actually going to change this to north just because it had a little bit more congestion going on. A little bit more consistent. So we're seeing quite a bit of congestion here. So we're going down and we're seeing actually the speed. So that's what I changed the metric to. So we're actually looking at the speeds here and how the speeds are changing. I'm going to stop this for a second. I changed this color thresholds up here to kind of look like a way that might be a little bit more consistent with what the road's actually looking like. What I would recommend on this right here, so if I'm looking at speed, for example, I would make the speed limit on that road green. So if I'm looking at a 60-mile-per-hour road, I might want to make that green here. If 75 is where I want to kind of monitor if someone is speeding, then I would put the blue here, 85 kind of up here. And again, kind of what would you consider a slightly congested condition, or someone going a little slower than they would at free flow speed? You might want to make that yellow, and again, kind of the red's indicative of where you would think kind of people are going a very slow speed versus a medium slow speed. So this kind of gives you a better look visually of what's going on. So I changed these up here, and now I'm looking at this roadway, and I'm able to see on a segment by segment level what's going on in this roadway at a particular time. So I'm looking at 12:30. I stopped it right here. And as I go down this 12:30, I can see exactly what's going on that road just by kind of digging down here, and you can see the segment moving on this road, and I can see where each of those individual segments are on the road. I can also say I'm actually very interested in this piece right here, maybe where this intersects with 10. I've been seeing some problem areas there, so I can actually just click on that individual spot, and I can go ahead and go through here, and I can see how it's changing over time, over kind of that entire daytime. So again, this is similar to the performance chart in that it's rolling up on the hour. The difference is that it's rolling up in the hour for each individual segment rather than for the corridor as a whole. So you're seeing a lot of the same values that you're seeing for the performance chart, but you're able to see it again on that segment by segment level. As you download that data, I'll go ahead and download just so we can take a look at it. As you download that data, that's again what you're going to see. You're going to see kind of those values. So right now I'm looking at speed, so it's going to download that speed for me. So I'm looking at each of those individual segments. Again, just to explain that a little bit further, the segments are the road segments that we break down our roads into. So these are our segment IDs. We allow you to, we can give you a kind of at no cost, a shapefile for that, for those. And so if you needed to put it on your own map, we can give that to you. But you're seeing the segment ID, as well as the segment length. And then you're seeing the speed, which is what we were looking at, the speed for each of those individual times. So for that 15-minute granularity that we chose for that individual segment, kind of over that entire week that we chose. So again, if we chose an entire month, it would be rolling up for that entire month on each of those individual hours. So that's what you're seeing here. This is a great way, again, to kind of get a better look at what's going on in a particular place. So again, we're looking at 101, but where are the actual problem areas? What are the actual problem times? So we're seeing a kind of a consistent problem time throughout this time range, but we're seeing kind of a little bit more issues kind of in this part of the roadway. If we look at south here, we're going to actually be able to identify even a little clearer what's going on because it's not quite as congested here. So if we look here, we can see that a lot of the problem segmentation is actually kind of in this place. So we might even want to go back and only select that piece of the corridor and even run the performance charts again on that. So it's kind of it can be an iterative process where you learn more and more about the individual corridor. The other piece here that you just need to know that you have is the change direction for the roadway. So this is intuitive to me because it's a 101 south. This is going south here. But if you're looking at, for example, an eastbound road and it's going down, that might not be intuitive to you. So you can just actually just change that direction here and make it kind of in a way that looks and feels the most intuitive to you. I'm going to, again, just do a quick stop just to make sure there's no questions, and then I'll go ahead and move on to bottlenecks.
So Angela, one question did come in, and it might be something that we have to do a follow-up on, but the question is, how is the accuracy of the data accounted year to year due to the advancement or change in the collection of probe data? And is any additional post-processing required for the older data to make it comparable to newer or more current data?
So that's a great question. We have we have quality metrics that we do kind of throughout the year on our data. So we have an I-95 validation, which you can see kind of at a quarterly basis, and that's actually where we're actually comparing our data to on-the-road sensors. So where we're looking at kind of loop sensors and comparing our data and making sure that we're within a certain validation range. So we have that piece of validation. We also have quality metrics that we're running continuously to make sure that we're meeting those. A lot of them are kind of around the idea of we gave an estimate that this time that this route would take kind of this long. Are we meeting that? So if we said something would take 10 minutes and then actually took 9 minutes, where were we kind of within that range? And using that kind of quality metric, we're able to determine how close we are and how accurate we are. So as long as we're meeting those quality metrics in terms of kind of the on the road validations as well as those internal quality metrics, we can kind of continue forward with it and say that we're being consistent at least year over year.
A couple more. Can you show congestion of roadway segments in both directions at the same time using offset?
So you can show in both directions. So I'm looking right here, and I'm able to see 101 north versus 101 south here, and so I'm able to see that. If I wanted to see, again, kind of the map player, then I would have to choose only one. So looking at 101 south, 101 north, and if I wanted to show the map player here, I would only be able to see one at a time. The offset is not something, I kind of would have to get a little bit back to you on that, but the offset is something we wouldn't necessarily take into consideration. When you choose the actual location that you're finding, it's going to take the segmentation that full segment. So it's not going to take that kind of piece of that segment, and it's going to calculate on that full segment. So if I looked here, for example, and I chose that individual spot, it's going to choose that full segment there. So even if I chose right here, which is in between that segment, it's going to calculate on that full segment, not on the exact point that you chose. So that's something that you would need to consider as well.
Thank you.
Okay, so moving over to bottlenecks. This is in the help section as well, which I'll go over, but bottlenecks are defined as the speed is getting to 65% of the reference speed, and we kind of give a trigger, and we trigger the system to say, is this a bottleneck? If it stays that way for 2 minutes, we say, yes, this is a bottleneck, and then we go back that 2 minutes, and that's the start of the bottleneck. And then that bottleneck continues until that speed gets to 75% of the reference speed, and then we say this bottleneck is over. So it's just kind of important to remember that's how we're calculating bottlenecks, and that's what you're seeing here. It's based on kind of how we've learned from our bottlenecks calculations in the past, and that's kind of the way that we found the most accurate way to get these bottlenecks. So that's what we're seeing here. So if we look at this bottlenecks here, we can see that it's sorted by impact factor. Impact factor is kind of a rough formula. So it's saying it's wanting to take into account occurrences, max duration, and max length. So it's wanting to look at all of those in combination. So it's just kind of multiplying those and saying this is the impact factor. So it's taking into consideration all of those. If you are only interested in occurrences or only interested in max duration, it might be better to look at just those individual columns rather than this impact factor. But you can see here it's sorted by impact factor. So we're going to take a look at this one with the most impact factor. So it has 13 occurrences. The average max duration is 138 minutes, and the average max length is 4.12 miles. So as we go down here, we can see that this is highlighted right here. So we're seeing this 101 south at this intersection, 101 exits 3AB. We can see this header here, the head of the bottleneck here, with the tail trailing up to it here. So we can take a look at that. And then we can see all of these 13 occurrences over here. So these colors here are kind of indicative of the severity of the bottleneck. So we're seeing some oranges here and one red. In relation, not too severe of bottlenecks, but you are seeing kind of a repetitive bottleneck going through this evening commute time, which is a little bit of what you'd expect. So as you're seeing kind of this is a general kind of problem area. It's happening kind of day over day. It's happening pretty repetitively, and it's almost happening at the same time as well. You are seeing some bottleneck over here and even a major one right here. So that might be correlated with maybe an incident that happened. So if you saw something like this green bottleneck right here, you're seeing that it's green, so it's very low severity. It also doesn't have any repetitiveness to it. This is probably an anomaly, something you wouldn't need to be concerned about. Whereas over here, you're seeing kind of, again, that continuous day over day bottleneck. And over here, you're seeing a severe bottleneck that seems a little out of place, so that might, again, be correlated with an incident. The other view you can look at here is kind of each of those individual bottlenecks here, and you're able to see the length of them, the time they started. So it's just a slightly different view of what's going on. I can also additionally see these over here if I click on these individual bottlenecks here. And I can choose to show the non-24-hour view if I want to see a little bit clearer and more zoomed in version of each of those individual bottlenecks. These bottlenecks are a great tool especially if you're starting out with kind of a region. So if I wanted to look, for example, at all of Los Angeles, it would be helpful to draw that entire region and then look at the bottlenecks for that entire region, because then I can kind of go, where are the major issues, where are they occurring for all of Los Angeles? And then I can utilize that to even look at individual corridors and to do more of my performance charts on an individual corridor level. So it's often a great start to just get a quick view of the entire region as well. As in all the other tools, I can download the data directly. and get information about each of the individual bottlenecks. One last piece here is that the different date ranges are available up here. So currently I'm looking at that 2018 timeframe, but if I wanted to look at the 2017, I would go here. Okay. So moving on to Data Downloader.
Really quick, Angela, there were a couple more questions that came in. There was one question that says, is it possible, and I think that you mentioned this at the beginning, is it possible to look at congestion for a region instead of corridor by corridor?
That is not possible right now. We have congestion scan available only for corridors, not by region. But again, the way to work around that in the tool is to utilize those bottlenecks, and then from those bottlenecks kind of get a better view of the corridors that you're interested in, and then go from there and kind of put each of the corridors into the tool. There's one other way of doing a corridor, of choosing a corridor. So if I go here, apologize I didn't mention this earlier, but you're also able to upload a segment list. So if there were a bunch of different corridors that you're wanting to look at and you weren't wanting to kind of individually click each of these spots, we could provide you with a segment list, and that could maybe potentially highlight this area, this. You know, highlight more of the roads, and from there you could kind of do a corridor analysis on those roads, which would give you that that congestion scan rather than doing it on the region level. So it's kind of a way around that. Okay. So going to Data Downloader, you can see I was at Bottlenecks and Data Downloader is available there. It's going to be available on any of the different modules. I'm going to go back to Overview just because it gives a better view of what's going on here. When you do the Data Downloader, you're going to download exactly the data that you've put on the Overview page. So again, I selected a granularity of 15 minutes, I've selected these dates, and I've selected this corridor. That's what it's going to download. So I'm going to go ahead and download this, and you can already see it's named, and it's consistent with what I was looking at. And then this is all the data that's going to download. Again, this data downloader is going to give you the data at the most granular level. It's something that you might need if you need to take it offline, but it is going to be a lot of data, so it's just something to keep in mind, especially as you're downloading it first, again, to maybe use those granularities at a 15-minute or an hour just to take a look at it. The things that it's going to download is the speed. So it's going to download the speed for every single 15 minutes for every single segment that I've selected. So I've selected here almost 40 segments. And so it's going to select 40, it's going to give me information for 40 segments on each 15-minute interval for the entire time that I've chose. So again, that can add up very quickly. So it's just important to remember how much data you're downloading. It's going to give me speed, historical average speed, reference speed, and travel time. I can additionally choose to only download the data that have real-time speeds associated with it. I'll talk about this in a second right here. I can also download time periods per day. So if I only wanted to download that morning commute, I can do that. And then we have these confidence values, which is again kind of back to that quality question that was asked earlier, where you're able to see where the data is coming from. So if you look at this confidence score, we have what we'll have is a 30, a 20, and a 10. A 30 is saying that value, that speed value, we're very confident that it's coming from real-time probes. With the speed score 20, we're saying that there's some values that might be real-time, but also it's in combination with some historical data. And a score 10 means it's lower confidence value, lower confidence data, and it's primarily from historical data or road reference speeds. So as you're looking at the data, it's kind of important to just take that into note. It's our way of making this more visible and more clear to you of where the data is coming from and kind of how many probes are behind that. And then we have this C value here. The C value is only correlated with those score 30, so that data that we're saying is definitely from real-time probes. And it's a 0 to 100 value, and it's really showing the consistency of the value. So it's really telling you for that value, is it what we would think it would be? Is it consistent with what we would think it would be? So it's not necessarily telling you that the value is bad or good. It's really telling you that it's not consistent. If something is at 50%, for example, It's saying that it's not quite consistent with what we would think we would see at this point. And it might be something to look into a little more. And then you can include this UTC date time here, which I would always recommend. And then as soon as you run the report, it's going to go ahead and show up in your My Documents. It's already complete, so I can go ahead and download it. You're going to get this metadata here, which again, I was talking about how we provide shapefiles at no cost. But here's also additional metadata. It's kind of the quick version of a shapefile, but it's just giving you the start, end, and start, end latitude and longitudes, and just kind of some basic information about the segment. And here's the data itself. So again, what I was saying is you are seeing each of those individual times. So you're seeing from kind of that 12 a.m. all the way down for each of these individual segments. So this is only one segment for all of this data. So you can see it's still only on one segment. Again, there's 40 of these different segments because it's giving for that individual segment, it's giving every single time, every single 15-minute time. You can see over here those values that I was talking about in terms of the score 30, score 20, and score 10. You can see here, so these are some of kind of the earlier values at 12 a.m. So you can see that we have some of the score 30 and some of the score 20 here. And as you get down to kind of some more normal times, starting at around 3:45 a.m., you're seeing that most of these are from real-time probes. So up here, you can see that there's this kind of 93 and 7. So 93% is score 30 and 7% is score 20. What you're seeing there is that we actually roll up our data from subsegments. So that's saying that of those subsegments that we rolled up, we're saying that some of those subsegments, just a few of them are score 20, but most of it here is score 30. So that's what you're seeing when you're seeing kind of those percentages there. And then you're seeing, again, these associated C values, which is what I was talking about, which is kind of a consistency indicator. So these are pretty high, but if you go down here, you see this 18 right here. So that's not quite consistent with what we would normally see, so it might just be something to look at. You can additionally see that this is a little bit more score 20 than it is score 30. So again, that might be something to just kind of look further into. Okay, so there's often some questions that come up around that data downloader, so I'll stop for a second.
Thanks, Angela. So a couple. One is, how do you define the reference speed? Is it the posted speed or other value?
The reference speed is, I can provide that to you as well, but the reference speed is defined essentially as a percentile of our national average speed. I think I can do a follow-up to this on exactly how that's calculated, but it's not quite just the posted speed. It's kind of the free flow speed is what we call it.
Got it. And we had another question, if there was enough time, if you could show everyone how to perform a bottleneck analysis by region.
Yes.
I don't know if we have about 9 minutes left.
Yes, I can do that.
Okay.
So we can just do a quick run on that. If you're wanting to select a region, again, so this is exactly how you'll see the page when you open it up in analytics.com. You're going to see, again, these aren't populated because I have not saved the study, so you're not seeing any population up here. You see the option to choose corridor or region, and again, the dates and granularity, which I've already showed. So I've already showed you how to select corridor. Now I'm showing how to select region. So I go ahead and add. Again, I can center on the region that I'm interested in. United States, California already selected. And then I would select the county that I'm interested in. So again, if I wanted to select different types of counties in California, I could choose that. I can additionally choose Los Angeles. Again, I can choose the road classes that I'm interested in if I'm really only interested in FRC1. And do FRC1 and 2. Hopefully it'll run a little bit quicker that way. So now I've selected all of Los Angeles, FRC1 and 2, and I will go ahead and add that location. And then I can add a date range. So I'm going to try to do, again, a kind of a shorter date range just so it runs a little quicker. I'm going to choose that 15-minute granularity again, and I'm going to click Save. And now you see this performance charts and bottlenecks show up. Again, the congestion scan doesn't show up, like I mentioned. And then we can generate reports on that. So this might take a little bit. It's going to take a little bit longer than just a corridor. As this is running, I'm just going to show you a few other things. So again, as you go over here, there's this help section. There's all the FAQs that I was talking about. So all the kind of basic information. This is kind of talking about that historical, the scores, the score 30 versus score 20 versus score 10 that I was talking about. What is an FRC, which is what I was just talking about, national interstates, regional highways, expressways, or what we're looking at right now for Los Angeles. How FD road segments differ from TMC segments, which is something you guys might be familiar with, and then other information. And then here's those data metrics, definitions I was talking about. How are we calculating speed, and how are we calculating travel time and historic average speed, and all of the information is kind of here on how we're doing that. And again, bottlenecks, which is what I talked about. How are we calculating bottlenecks? We additionally have a guide to roadway analytics. This is a great tool if you're kind of wanting a quick overview of what I just went through, and it'll take you through each of the individual performance charts, congestion scans, etc. And then we have over here, your account. So this is kind of just a basic thing, but it's important because it will look different based on what you choose. So here's where you'll be able to change your password as soon as you get that password reset email. And then there's preferences. This is where you choose your language, English, German, Spanish. It's additionally where you can have this date format that you're interested in. And here's the time zone. This is where it's really important to have correct. We do offer the ability for customers to change this because there's customers that often work in different time zones. So it's just important that you're on the correct time zone when you're doing this, or your performance charts will obviously be a little bit skewed. If I was running on an EST time zone while I was doing a Los Angeles report, it's going to look like there's congestion when at a time that there's not. So that's just an important piece there. And then units here, make sure that you're on the correct unit that you're wanting to utilize. Go over here and see this run. So here we have for Los Angeles, only for those FRC ones. You're seeing some of the areas that are kind of the highest bottlenecks. So you can see pretty quickly some of these roads. So you have this impact factor here, and you're able to see some of the roads that you might be interested in kind of taking a deeper dive on by just going through and taking a look at where the roads are that you're most interested in. Again, as you're clicking through, you're able to see them actually on a map and take a look at each of the individual bottlenecks. Okay.
So there's a couple more questions. Real quick. What is the turnaround time on a no-cost shapefile, and what is the process when encountering road segment gaps or missing routes?
The turnaround time on a shapefile is for kind of a standard state shapefile, which we have typically. That would be fairly quick, a day. But for something that's specific, for example, if you needed a shapefile for a zip code, or you needed a shapefile for several different counties, that takes a little bit longer, a couple days, maybe 3 days. So it's a little bit longer for those. If you just wanted a state or a country, kind of a typical zone, those are very easy for us to provide. What was the second question?
Oh, just following up is, and what is the process when encountering road segment gaps or missing routes?
So when you encounter road segment gaps, the best thing to do is to take a screenshot of it and send that information to support@inrix.com. We will then place it into our kind of map update queue. We have a map twice a year. So if you see any gaps that you're interested in adding in different roadways, that's the process for that. So again, that's support@inrix.com.
Great. And then another, how does the quote-unquote not show roads that have real-time speeds option box correlate to the scores or values?
So what you'll see if you choose that option is essentially none of the values that don't have a score 30. So let's see if there's any in this. So if we're seeing anything that's 0 here. So there's a few values that are 0. None of these will download. So it'll only be things that don't have 0 that will download. So it'll essentially look like this.
Awesome, thanks. And the last question I have in the queue here is, can we change the road classification at the user end?
You cannot change the road classification at the user end. That's something that is specified kind of deep into the map process. There are other routes of finding information. So I'm not sure where that question is coming from, but often we have customers who are wanting, for example, to use all I roads, so all interstate, and FRC doesn't necessarily correlate with all I-10 or I-5. So what we can do is we can provide an XD segment list for your particular area. So if you were looking at for all of Los Angeles, for example, and you wanted all the I roads, and you didn't want to have to kind of have them to be dependent on FRC, we can provide you with a segment list that has only those I roads, and that's kind of a way around that as well.
Thank you. Well, we timed that really well. So I think that we're just at the hour here, so we'll wrap this up. I want to just thank you all for joining the training today. A very special thanks to Angela for her time and expertise on our roadway analytics platform. Again, she mentioned that if you have any questions in the meantime, we will dive into these questions. And if there's any follow-up needed, please don't hesitate to contact Angela. Her email address is angela.salerno@inrix.com or support@inrix. And again, the training has been recorded, and you will all be emailed a link to that recording within 24 hours. You'll usually see it. You'll probably get it tomorrow in the AM. And yeah, thank you all for joining. That concludes our training today. Have a wonderful day.